In last video, we have discussed about heat and temperature. At last, I asked you a question. Does transfer of heat energy takes place in all situations or not? Does transfer of heat energy takes place in all situations? Let's see about it. Yes, to know about it, we have to do an activity. Before doing an activity, let's discuss about the concept. Yes, so let's see about it. So, first take two bodies. After taking two bodies, name them as A and B. Yes? Yes. First body is named as A and second body is named as B. So first body A is having 120 degrees Celsius and B is having 80 degrees Celsius. Yes? Yes. So which is having higher temperature? Already we know heat flows from a body at a higher temperature to a body at lower temperature. So heat energy flows from where to where? From 120 degrees Celsius to 80 degrees Celsius. So when it is transferring, what happens? When this 120 degrees Celsius flows towards the 80 degrees Celsius, this B gains the heat energy and A will lose the heat energy. Yes? Yes. So when it gains 20 degrees Celsius, here A will lose 20 degrees Celsius. So when it gains 20 degrees Celsius, A will lose 20 degrees Celsius. So then what happens to its temperature? In 120 degrees Celsius, if it loses 20 degrees Celsius, what is its temperature? Its temperature is 100 degrees Celsius. If it gains 20 degrees Celsius, at first it is having 80 degrees Celsius. After gaining 20 degrees Celsius, how much temperature it is going to have? It is going to have 100 degrees Celsius. Yes? Yes. So, here A is having 100 degrees Celsius now and B is having 100 degrees Celsius. So, both are having same temperature. Yes? Yes. So, when both bodies are having same temperature, then heat will not be transferred. Yes? When both bodies are having same temperature, transfer of heat energy will not take place. When both bodies are having, if one body is having higher temperature and another body is having lower temperature, then transfer of heat takes place. But if both bodies are having equal temperature, at that time the transfer of heat energy will not take place. Love, you understood? Yes. So when both bodies are having equal temperature, that state is called as a thermal equilibrium. What we call it as a thermal equilibrium. Yes, when we take two different bodies, when we kept that two bodies in thermal contact, when they are in thermal contact, then what happens? Heat energy will be more to the two bodies. When they both are having same temperature, that state what we can call it as a thermal equilibrium. Both bodies are in thermal equilibrium. Yes? Yes. So let's see about it. Thermal equilibrium. Heat and temperature. Yes. Now you know what is thermal equilibrium? Already I explained you what is heat and temperature. Yes. Yes. So to know more about it, we have to do an activity. Now let's do an activity. To do that activity, first we have to take two glass tumblers. Yes. So to do activity what we need? We need 2 glass tumbler. For what sake we are doing now activity? To know more about thermal equilibrium. Yes, yes. So first take 2 glass tumblers. Yes. So in first tumbler we are going to place hot water. In second tumbler we are going to place cold water. So in first tumbler we are going to place hot water. In second tumbler what we are going to place? Cold water. HW means it's not homework. CW means it's not classwork. HW means hot water and CW means cold water. Yes, yes. So after taking glass tumblers with hot water and cold water, just place a thermometer. First you place that thermometer in hot water. Yes, yes. So when you place the thermometer in hot water, what happens to the mercury level of thermometer? When you place a thermometer in hot water, what happens? The mercury level of thermometer automatically will increase because of hot water. Yes, what happens? The mercury level in the thermometer will be increased. And same thermometer, you take it out and keep in cold water glass tumbler. So when you keep same thermometer in cold water, what happens? The mercury level of thermometer will be decreased. What happens? The mercury level of thermometer will be decreased. When you keep a thermometer in hot water, the mercury level will be increased, and when you keep thermometer in cold water, automatically the mercury level will be decreased. So when we get the steadiness of the mercury column of the thermometer, when thermometer and water have same temperature. If they both are having same temperature, we get a steadiness of mercury column of thermometer. Yes? Yes. Okay. So if thermometer and water having same temperature, at what state they are? They are in thermal equilibrium state. If two bodies at same temperature, we can say that they both are at thermal equilibrium state. Yes. So when we get steadiness reading, when they both are in same temperature. Yes. Yes. If it is having higher temperature, it will be raised. If it is having lower temperature, here the mercury level will be decreased. If both are having same temperature, then we get the steadiness of mercury column. Yes, yes. When we get steadiness of mercury column, that state can be called as thermal equilibrium. Yes, all of you understood? Yes. To make you understand better, I will give one more example for it. Yes, yes. Just take two different systems. Yes, system A and system B. Yes, just take two different systems, system A and system B. Keep it in thermal contact. When they both are in thermal contact, will it be in thermal equilibrium state or not? Let's see. Yes, when you keep A and B in thermal contact, they will be in thermal equilibrium state or not? We will see now. Yes, yes. After taking A system and B system, next you take C. Yes, next you can take C. Already we know that C and A, if you place C and A in thermal contact, they both are equal. They both are equal. If you place A and C in thermal contact, they both are equal. And next, if you place B and C in thermal contact, they both are equal. Yes, they both are equal. For example, C is having 50 degrees Celsius. You kept in thermal contact. They both are equal means A is also having 50 degrees Celsius. Yes, yes. And here C is having 50 degrees Celsius. and when they are in thermal contact, we are saying that they both are equal. That means B is also having 50 degrees Celsius. So, what we are doing now? We want to know if A and B are in thermal contact, will it be in thermal equilibrium state or not? Yes, we know that A is equal to C and B is equal to C. When they both are equal, if you keep A and B in thermal contact, will it be equal or not? They will equal because A is having 50 degrees Celsius and B is having 50 degrees Celsius. When they both are having same temperature, they will be in state of thermal equilibrium. Yes? Yes. So, here what we can say, A, B, C are in thermal equilibrium state. Yes, when A, B, C are having same temperatures, what we can say, A, B, C are in thermal equilibrium state. Yes, all of you understood? Yes. So, now you know what is thermal equilibrium? Heat and temperature. Yes, yes. So, what are the units of heat and temperature? Let's see about it. What are the units of heat and temperature? Yes, the SI unit of heat is joules. Yes, what is SI unit of heat is joule. Yes, SI unit of heat is joule. And CGS unit of heat is calorie. CGS unit of heat is calorie. What is calorie? What is calorie means the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius is called calorie. Once again I am repeating for you. What is calorie? The amount of heat required to raise temperature of 1 gram of water by 1 degree Celsius is called calorie. And 1 calorie is equal to 4.186 joules. Yes, what is the value of 1 calorie? 1 calorie is equals to 4.186 joules. Yes, now you know SI unit of heat is joule and CGS unit of heat is calorie, and value of 1 calorie is equals to 4.186 joules. Now let's see about SI unit of temperature. Yes, SI unit of temperature. So what is SI unit of temperature means Kelvin. What is SI unit of temperature? Kelvin. You can measure temperature in Kelvin, or else you can also measure in degree Celsius. You can also measure in degree Celsius. Yes, temperature can be measured in Kelvin or else in degree Celsius. Yes, so 0 degree Celsius value is equals to 273 kelvins. Yes, the temperature can be expressed in Kelvin or else in degree Celsius. The 0 degree Celsius is equals to Kelvin. If you want to convert degree Celsius value into Kelvin means what formula you have to use means temperature in Kelvin. Temperature in Kelvin is equal to 273 plus temperature in Celsius. Yes, do you understood? If you want to convert degree Celsius value into Kelvin means what you have to do means temperature in Kelvin is equals to 273 degrees plus temperature in degrees Celsius. Yes, have you understood? So if you want to convert degree Celsius value means what you have to do? What you have to do, if you want to convert this degree Celsius value into Kelvin means you have to do plus 273. If you do plus 273, degree Celsius value will be converted into Kelvin scale value. Yes, yes. So what is temperature? Already you know, it is measure of degree of hotness or coldness. Yes. So what is absolute temperature? What is absolute temperature means if temperature is measured on Kelvin scale, that is called as a absolute temperature. Yes. So what is absolute temperature means if temperature is measured on Kelvin scale, that is called as a absolute temperature. So next concept is about temperature and kinetic energy. Let's see about it. So what is the relation between temperature and kinetic energy? Yes, what is the relation between temperature and kinetic energy? Let's see about it. Yes, to know about relation between temperature and kinetic energy, we have to do an activity. That is third activity. Let's do it. To do third activity, we have to take two bowls. Yes, so take two bowls. Yes. So in first bowl, you have to take hot water. Hot water. And in second bowl, you have to take cold water. Yes. So in first bowl, what we took? We took hot water. In second bowl, we took cold water. Yes. So after taking hot water and cold water, what you have to do means you just sprinkle food color. Sprinkle food color or else food color or else potassium permanganate. Yes. After taking hot water and cold water, you just sprinkle food color or otherwise potassium permanganate. Yes, so potassium permanganate will not be available to us, so we will take food color. Yes, so after taking food color, you just drop some food color into it. So when you sprinkle that food color into it, what happens? First we will take hot water. Yes, if you observe hot water, what happens means when you sprinkle that food color into hot water, what happens? They move randomly because the water molecules present in bowl will move randomly. When water molecules move randomly, automatically the food color particles also move randomly. Yes, yes. Here also, if you observe in cold water, this cold water molecules will move randomly. When cold water molecules move randomly, the food color particles also move randomly. Yes, but here if you observe in hot water, food color particles will move rapidly. Yes, food color particles move rapidly. Why? Because it is in the presence of hot water. Yes, it is having some more energy. Yes, it is having heat energy. So because of heat energy, the food color particles will move rapidly. Here what happens? It is having cold water. It is not having any more energy. Yes, when it is not having more energy, what happens? The food particles, the food color particles will move randomly but not rapidly. Yes, yes. So if you observe here, if temperature is more, when heat energy is there, food color particles, the grains of food color are moving rapidly, very fastly. Yes, you know that when a body possesses kinetic energy, a body possesses kinetic energy when that body is in motion. Yes, yes. So when the body is in motion, it possesses kinetic energy. So here the grains of food color particles, what happens? They are in motion. That means it somewhat possesses kinetic energy. So here what happened? The grains of food color particles move slowly. Yes, so when they move slowly, the kinetic energy will be less. Yes, so when they move slowly, the kinetic energy will be less. So what we can say? We can say that the average kinetic energy of the grain of food particles in hotter body is greater than the average kinetic energy of the particles of the colder body. Yes, so it is having higher kinetic energy, it is having lower kinetic energy. Why? It is having more temperature, it is having less temperature. That means when temperature increases, kinetic energy increases. When temperature decreases, its kinetic energy decreases. So by this, what we can say? The temperature is the indicator of kinetic energy. Yes, so temperature is indicating that body's kinetic energy. Yes or no? Yes. So the temperature is indicating its kinetic energy. So what we can say? The temperature is the indicator of the average kinetic energy of the molecules of the body. Yes. Yes. So what we can say? We can say that the kinetic energy is directly proportional to temperature. Yes. So what is the relation between the temperature and the kinetic energy? Means the temperature is directly proportional to kinetic energy. Yes, if temperature increases, kinetic energy increases. If temperature decreases, kinetic energy decreases. Yes, yes. So what is the relation between the temperature and the kinetic energy? Temperature is directly proportional to kinetic energy. In next video, we will discuss about fourth activity. If you like the videos, please subscribe to my channel, like, share, and if you are having any doubt, just comment me down.